Imagine standing beneath a sky where the weather forecast isn't rain, snow, or hail. It's liquid iron. Not tiny metallic particles, not rusty dust drifting through the atmosphere. Entire storms of molten iron heated to thousands of degrees, falling from the sky like glowing rivers pouring out of the clouds. It sounds like something from science fiction, but astronomers say it exists. Roughly 640 light-years from Earth, they found a planet so extreme that it rewrote what scientists believed weather could be. A world where temperatures are high enough to melt metal, where winds scream across the atmosphere at thousands of miles per hour, and where one side never sees night. The planet is called WASP 76b, and the deeper scientists looked, the stranger it became. When WASP 76b was first discovered, it immediately stood out. It wasn't just another giant planet orbiting another distant star. It belonged to a class known as an ultra-hot Jupiter. These are enormous gas giants that orbit unbelievably close to their stars, sometimes completing an entire year in less than 2 Earth days. WASP 76b circles its star in only about 1.8 Earth days. That tiny orbit changes everything. The planet is so close to its star that gravity has locked one side permanently toward the light, just as our moon always shows the same face to Earth. One hemisphere experiences endless daylight. The other is trapped in eternal darkness. There is no sunrise, no sunset, only an endless boundary between fire and shadow. Scientists expected extreme temperatures. They didn't expect weather unlike anything in the known universe. Using one of the world's most advanced observatories, astronomers analyzed the planet's atmosphere as it passed in front of its star. Instead of taking pictures, they studied tiny fingerprints of light. Each chemical leaves behind a unique signature: hydrogen, sodium, calcium, iron. And that's when something impossible appeared. Iron gas. Not solid iron, not molten iron, iron floating as vapor. Temperatures on the day side exceed about 2,400 degrees Celsius, hot enough to vaporize metals that remain solid almost everywhere else. Mountains on Earth would melt, steel buildings would collapse, nothing familiar could survive. Yet on WASP 76b, this is simply the normal afternoon. But one discovery raised an even bigger question. If iron becomes vapor in the blazing daylight, where does it go? Scientists realized something remarkable. Powerful winds race around the planet at several kilometers per second, carrying that vaporized iron away from the scorching day side toward the permanently dark hemisphere. Imagine hurricane-force winds transporting clouds made of metal across an entire planet. As the iron gas reaches cooler regions, temperatures begin to fall. Not cold by Earth standards, still hotter than lava, but cool enough for something extraordinary to happen. The vapor can no longer stay suspended. It begins to condense, exactly as water vapor forms rain clouds on Earth. Except these clouds aren't made of water, they're made of iron. The prediction sounded almost unbelievable. Clouds of metal, rain made from molten iron. Even many astronomers wondered whether nature could really behave this way. Then, more observations arrived. Using increasingly precise instruments, researchers detected evidence that supported an enormous temperature difference between the two hemispheres and found signs consistent with iron moving across the atmosphere. The pieces fit together. A furnace on one side, a cooling zone on the other, metal carried by somewhere beyond the edge of eternal daylight, iron falling back toward the planet below. It became one of the most extraordinary weather systems ever proposed. But just when scientists thought they understood how this alien world worked, they noticed something in the atmosphere that shouldn't have been there at all. Something moving in a way no existing model had predicted. And that unexpected clue completely changed the mystery. The new clue came from the planet's evening edge, the narrow region where eternal daylight meets endless night. Astronomers expected to find iron there. Instead, they found iron moving away from the hottest region, carried by winds so powerful they reshaped the planet's entire atmosphere. These weren't ordinary winds. Scientists estimate they travel at several kilometers per second, far faster than the strongest hurricanes on Earth. At those speeds, the atmosphere doesn't simply circulate, it transports enormous amounts of heat from one side of the planet to the other. That changes everything. On the blazing day side, temperatures climb above 2,400 degrees Celsius. That's hot enough to vaporize iron into gas. The supersonic winds then sweep that iron vapor toward the permanently dark hemisphere. As the gas enters cooler regions, it begins to condense, not into water droplets, into droplets of molten iron. In other words, the planet appears to have a weather cycle built from metal instead of water. Scientists wanted proof, so they studied the planet using one of the most powerful observatories on Earth, the Very Large Telescope in Chile. By analyzing tiny changes in starlight as WASP 76b passed in front of its star, they detected iron signatures that were stronger on one side of the atmosphere than on the other. That was exactly what researchers would expect if iron were being transported across the planet before condensing in cooler regions. The evidence didn't show individual raindrops, but it revealed the conditions needed for molten iron rain to exist. Then another surprise emerged. The hottest point on the planet wasn't directly beneath its star. It had shifted eastward. That meant the violent winds were moving heat faster than expected, pushing the hottest region away from the point receiving the most sunlight. The atmosphere itself had become a giant engine, constantly redistributing energy across the planet. Imagine a world where the weather never stops, where daylight lasts forever, where darkness never ends, where metal evaporates, travels across the sky, and falls again as glowing liquid rain. No human could ever stand beneath those clouds. The atmosphere is made mostly of hydrogen and helium. The pressure is immense. The temperatures are lethal. Yet this hostile world has become one of the most important laboratories for planetary science. Every new observation helps researchers understand how giant planets behave under extreme conditions. It also reveals something even more exciting. WASP 76b is probably not unique. Astronomers have already discovered thousands of exoplanets, and many of them are even stranger. Some may have clouds made of vaporized rock. Others could experience storms of molten minerals or atmospheres filled with exotic chemicals unknown on Earth. The universe keeps reminding us that our planet is only one small example of what a world can be. Perhaps the most astonishing part of this discovery is how it was made. No spacecraft has visited WASP 76b. No probe has flown through its atmosphere. Everything scientists know came from faint changes in starlight traveling hundreds of light years across space. From those tiny signals, they reconstructed an alien world with blazing heat, supersonic winds, and skies that may rain molten iron. It's a reminder that the universe is far more creative than our imagination. For centuries, people looked into the night sky and wondered whether distant planets might resemble Earth. WASP 76b gave us a very different answer. Some worlds are so extreme that they force us to rethink what weather, climate, and even a planet can be. And somewhere, nearly 640 light-years away, beneath an endless alien sky, the iron rain is still falling.